Okay, just going to look at sketching polynomials. Polynomials. Alright, so if we can look at this first one here and then this second one here. So first of all, when we're looking at these here, we look at each of these as separate components. And what we're doing is we need to find the zeros or the roots. So that means that when p of x equals 0, you'll get where it cuts the x-axis. So that'll be at x equals 0, that's the first one. X minus 3 equals 0, that means x equals 3. And x plus 4 equals 0, so that means x equals minus 4. So that means it goes through 0, 3, and minus 4. Now basically these are just single roots, so it just cuts the axis there. And the other thing too is you need to just make sure that you have a really good look at when you expand this. If you look at the x terms, that would be a positive x cubed. If it is a positive x cubed, it will always start up here in the positive quadrant. So it's going to start there. And if you draw these backwards, don't draw them forwards, draw it backwards. So always I want you to start on the right. And if it is a positive x cubed when you expand it, then start on the right and start in the positive quadrant, which is quadrant 1. So let's go down. We cut here, come back up, cut there. We don't know how high we go. We'd have to use calculus to find that. And then cut it 4, and that would be your polynomial. See, this one here, it's going to start in this quadrant here, in quadrant 4. So the negative tells you that would start in quadrant 4. Okay, now we need to get the zeros. Right, so if we make 2x minus 1 is 0, you get x is 1 over 2, or a half. X plus 3 is 0, so x is minus 3. And x minus 4 is 0, so x equals 4. So we are going to go to cut at 1, 2, 3, 4. There's 1. Minus 3. 1, 2, 3. Minus 3. And then we're going to also cut at a half. Okay. So it needs to start down in that lower quadrant down here, because it's a negative one. Cut at 4, come up, cut at a half, come up, and cut at minus 3. Now in both of these, you've got to make sure that you do get the y-intercepts. That one you have. This one, we need to put in x equals 0. So in order to do this, so if we put in x equals 0, and we put that into the equation of that polynomial, so p of 0 equals minus 2 times 0 minus 1, 0 plus 3, 0 minus 4. You get minus 1, which is plus 1, times 3 times minus 4. You end up with minus 12. So that means that this here, this y value here, even though it's not very good scale here, that will be minus 12. So, and that's the x and the y-axis. You need to mark in the intercept on the y-axis. Okay, so if we look at, let's just have a look at another one. So I want to look at a couple that have double roots and single roots. Okay, so let's go p of x equals, let's go x minus 3, and we'll put a square, x plus 4. Okay. Alright, so just note that one there, it has a double root, because if you have a 2 on there, you write it twice, and that's x plus 4. So that one's a double one. So when you solve that for 0, so you get x is 3, and x is minus 4. So that's telling you that there is a double root at 3. and there is a single root at minus 4. I just had 4, it should be minus 4. And it is a positive x cubed, because that would be positive x squared times x. That's going to start up here. So if we go to draw it now, it has to touch at the double root. So if it's a double root, it will touch like a parabola. If it's a single root, it will cut. So it's going to come up here, back down, and it is going to cut. Okay. Now, if you put in x equals 0, so you put in x equals 0, p of 0 is 0 minus 3 squared, 0 plus 4. Minus 3 squared is 9, plus 4 is 4. 4 nines are 36. So that means that in here, that means it's going to cut. Let's do that like that. It's going to cut at 36, and there's your x, y, and we better just put the 0 in there. So things to note is that if it has a square on it, it is a double root. Now, that will also work if you have any even indices. So if you're looking at that and you have p of x, and you go p of x is equal to, and let's go x minus 1. If we do to a power of 4, it would be exactly the same scenario. Now I'm going to put a minus in front of there as well. So it goes through 1 minus 3. And minus means it's got to start down here. So it's going to touch. It'll just be a little bit flatter. Come down. It's got to go back up. And it's got to cut at 3. Okay, so that's x, that's y. And that's what your polynomial would look like. Put in x is 0. You get minus 0 times minus 0 minus 1 to the power of 4. 0 plus 3. So that's going to give you minus 3. So that's minus 3 down there. Okay. So let's just look at, I just want to look at if it's an odd power. So if it is an odd power, let's have a look at that. We'll get rid of that. So let's just say we have p of x equals x, and we're going to go x plus 1, and we're going to go to the power of 3, and then x minus 2. Alright, so looking at this, our roots are at, when you make that equal to 0, the roots are at x equals 0. X equals minus 1, there are 3 roots, so we call that a triple root. And x equals 2 will be a single root. Okay, so there, and there. It is a positive x cubed, isn't it? Because you got x times x cubed times x. So we're going to start here. That one will cut. That one's a cubic. And this one will cut. So it's going to go cut, cut. Now when you go to draw your cubic, you're probably better off doing half a parabola up, half a parabola down, and then get this one to curve around and drawing it. So there's the x and there's the y, and we already have our y-intercept. So if we just look at one where we just combine these things together, so if I look at p of x equals x 2x minus 1 to the 4, x plus 3 to the power of 3. Okay, so we have our roots here. We go 0, that one will cut, that one's like a parabola, and that one's like a cubic. The root here is 2x equals a half. So then you get x equals a half. So it's going to be x at a half. And then this one's going to be minus 3. And it is a positive one, so it's going to start here. So x equals a half, it does look like a parabola. Come back. It's got to cut at 0. And then this one here has to go like a cubic. So draw it first, and then you're better off joining it up. And that's your curve. And there's your x and your y, and the intercept's already done.